The Nano World Introduction. Scientific researchers have developed new technological tools that greatly improve different aspects to our lives. The use of nanoscale is one important interdisciplinary area generated by advancement in science technology. Research and application of knowledge on nanomaterials will continue to bring widespread implication in various areas of the society. Nanotechnology is the study and implication of expectationally small things in other areas in science, such as material science, engineering, physics, biology, and chemistry. Nanoscience and nanotechnology employs the study of expectationally tiny things in a variety of fields, including material science and engineering. The concept of nanotechnology and nanoscience started in 1959 when physicist Richard Feynman discussed a method in which scientists can direct and control individual atoms and molecules. The term nanotechnology was coined by Professor Norio Taniguchi. It's designed after the dawn of the use of the ultra precision machining. How is small a nanoscale? A nanometer is a billionth of a meter or 10% of a meter. The illustration below to show how small nanoscale is compared to other particles or materials. Manipulation of nanomaterials need an adept understanding of their types and dimension. The various types of nanomaterials are classified according to their individual shapes and size. They may be particles, tube, wires, and films, flakes, or shell that have one or more nanometer size dimension. One should be able to view and manipulate them so that we can take advantage of their exceptional.
Okay, so how to view a nanomaterial? Scientists are a special type of microscope to view minute nanomaterials. During the early 1930s, scientists used electrons microscope and field microscope to look at the nanoscale. The scanning tunneling microscope and atomic force microscope are just among the modern and remarkable advancements in microscopy. So first is the electron microscope. German engineer Ernst Ruska and Max Knoll built the first electron microscope during the 1930s. This type of microscope utilized a particle beam of electron to light up a specimen and develop a well-magnified image. Electron microscope produce higher and better resolution than older light microscope because they can magnify object up to a million times, while conventional light microscope can magnify objects up to 1,500 times only. So the electron microscope, based on the statement, can magnify images up to a million times, much better than the others because the conventional light microscope can only magnify objects up to 1,500 times only. So next is the atomic force microscope or AFM. It was first developed by Gerd Binig, Calvin White, and Christoph Gerber in 1986. It makes use of a mechanical probe that gathers information from the surface of a materials. Number 3 is the scanning tunneling microscope. This special type of microscope enables scientists to view and manipulate nanoscale particles, atoms, and small molecules. In 1986, George Binig and Heinrich Rohrer won the Nobel Prize in Physics because of this invention.
Sinasabi dito na ang nanomanufacturing is both production of nanoscale materials na maaaring powder or fluid. The manufacturing of part is bottom-up from nanoscale materials or top-down is smallest step for high precision, which ginagamitan to ng mga technologies such as laser, ablation, etching, and etc. Bottom-up fabrication, it uses chemical and physical forces. Pinaghiwalay nito ang mga simple units into larger structure. It approach mimics biological process na kung saan the individual atoms pile of one after the other on a substrate at nagpo-form ito ng molecules. It is sculpting from a block of a stone, and a piece of the base materials is gradually eroded until the desired shape is achieved. That is, you removing materials for it where it not required. There are new approaches to the assembly of nanomaterials based from the application of principles in top-down and bottom-up fabrication. These include deep pen lithography. It is scanning probe lithography techniques where an atomic force microscope or AFM tips used to create pattern with a range of substance with a variety of inks. Self-assembly, wherein a set of components join together para bumuo ng isang structure in the absence of an outside directions. Tapos ang chemical wave for deposition naman, it is a procedure na kung saan the chemicals get in response for its form very pure, high-performance film. The nano-imprint lithography, ginagamit ito ng mga nanoscale attributes by stamping or printing their onto a surface. Beam epitaxy is one of the manner na kung saan sila yung nagko-contour to the thin films. Tapos ang roll-to-roll, it is a high volume to practice constructing nanoscale devices on a roll of thin plastic or metal. And yung atomic layer epitaxy naman it is for laying down one atom layer on a surface. Sinasabi nga dito na with the use of these techniques, nanomaterials made more durable, stronger, light of water repellent, ultraviolet, and so on. And above-mentioned characteristic lead to the manufacturers of the present variety of nanotechnology, enable like tennis, rackets, and the baseball bat, and for purifying crude oil, and ultra-sensitive and clarification of biological and chemical toxins.
Distinct features of nanoscale. Nanotechnology involves operating at a very small dimension, and it allows scientists to make use of the exceptional optical, chemical, physical, mechanical, and biological qualities of materials of that small scale. NNI 2017. The following are distinct features of nanoscale. Number 1 is scale at which much biology occurs. Various activities of that cells take place at that nanoscale. The deoxyribonucleic acid DNA serves as the genetic material of the cell and is only about 2 nanometers in diameter. Hemoglobin that transports oxygen to the tissues throughout the body is 5.5 nanometers in diameter. Modern researches focus on advancing procedures, therapies, tools, and treatments that are accurate and custom-made than traditional methods and cause no adverse effects on the body. An example of this is the biobarcode assay, which is a fairly expensive approach for identification. Number 2 is scale at which quantum affects domain properties of materials. Particles with dimensions of 1 to 100 nanometers have properties that are significantly discrete from particles of bigger dimensions. Quantum effects direct the behavior and properties of particles in the size scale. The properties of materials are highly dependent on their size. Among the essential properties of nanoscale that change as a function of size include chemical reactivity, fluorescence, magnetic permeability, melting point, and electrical conductivity. One example is the nanoscale gold, which is not only the yellow-colored element we are used to seeing, but it can also appear red or purple. Gold's electrons display restricted motion in the nanoscale. Particularly, nanoscale gold particles electivity build up in tumors where they permit both precise imaging and target laser destruction of the tumor while avoiding damage on healthy cells. Number 3 was nanoscale materials have far larger surface areas than similar masses of larger scale materials. If a cubic centimeter is filled with micrometer-sized cubes a trillion, 1012 of them, each with a surface area of 6 square micrometers, the total surface area amounts to 6 square meters. This is about the area of the main bathroom in an average house.
Government funding for nanotechnology in different countries, Dayre 2005. 1. U.S. National Nanotechnology Initiative. The best known and most founded program is the National Nanotechnology Initiative of the United States. The NNI was established in 2001 to coordinate U.S. federal nanotechnology R&D. The NNI budget in 2008 and 2009 were $1.4 billion and $1.5 billion respectively. 2. European Commission. In February 2008, the EC official launched the European Nanoelectronics Initiatively Advisory Council. 3. Japan. Nanotechnology Research Institute under the National Institute for Advanced Industrial Science and Technology EIST. 4. Taiwan. Taiwan National Science and Technology Program for Nanoscience and Nanotechnology. 5. India. Nanotechnology Research and Education Foundation. 6. China. National Center for Nanoscience and Technology. 7. Israel. Israel National Nanotechnology Initiative. 8. Australia. Australian Office of Nanotechnology. 9. Canada. National Institute for Nanotechnology or NINT. 10. South Korea. Korea National Nanotechnology Initiative. 11. Thailand. National Nanotechnology Center or Nanotech. 12. Malaysia. National Malaysian Nanotechnology Initiatives or NINI. Possible applications of nanotechnology in the Philippines, Dayre 2005. 1. ICT and semiconductors. 2. Health and medicine. 3. Energy. 4. Food and agriculture. And 5. Environment. Nanotech Roadmap for the Philippines, founded by PCES, TRD, DOST. 1. ICT and semiconductors. 2. Health and biomedical. 3. Energy. 4. Environment. 5. Agriculture and food. 6. Health and environmental risk. 7. Nanometallurgy. And 8. Education and public awareness.
What the benefits of nanotechnology? Nanotechnology is the helping to considerably improve the even the revolutionize many technology in industry sector, homeland security, medicine, transportation, energy, food safety, and environmental science among many others. What is the benefit of nanotechnology during environment? Beyond clean energy, nanomaterials offer the manufacturer the ability to improve the environmental performance of the product by enabling there to reduce toxicity, increase the durability, and improve energy performance. What is the benefits during the medicine? It's the important standpoint and that can also be vital from the diagnostic perspective by using nanoparticles. A drug can be accurately delivered to the targeted region in the body. What is the benefit and economy? Has significantly contributed to society in shaping the nature of modern life. Nanotechnology can the economic the growth as well the improve the capacity and quality in industrial sector. Possible the benefits. So, yun, during the nanotechnology, kung saan ay invented ng mga scientists upang ito makatulong mapabilis, lalo na sa mga during the economy, mga gamitan ng bagong technology na upang lalong mag-grow, lalong mapabilis yung ah, paggalaw ng ekonomiya ng mga bagong kagamitan na possible na mabilis yung pag-unlad ng isang bansa o ng isang lugar, lalo na dito sa health, yung pagsiyasat o pag-aaral ng mga gamot na sinisigurado to assure the B-shape sa lahat ng taong makakuha ng mga gamot. So, sa mga pagkain, so, yung mga bagong technology na kung saan ay sinisiyasat nila na magiging maayos, magiging malinis bago nila ito magiging approved sa FDA.
Summary: nanotechnology is an advanced, interdisciplinary field that encompasses the science and technology that produce materials that are a great help in improving various areas of society, especially healthcare, environment, energy, food, water, and agriculture. This is a field that need to be explored not only by renowned experts but also by neophytes. To advance our knowledge of science and technology, and above all, to help improve the quality of our lives. But before we engage in nanotechnology, we need to consider the social, ethical, and environmental concerns of using such as nanomaterial.